My dear students, in this video, we will be solving problems from differential equations. The problems are from previous year Cbse board question paper. Before solving the problems, let's quickly revise what is coming in our paper. First, order and degree, general and particular solution of a differential equation, solution of differential equation by various methods, which are method of separation of variables, solution of homogeneous differential equation of first order first degree of the type dy by dx is equal to f of y by x. Why they have mentioned this? Because they are not, they don't want you to solve the questions dx by dy form. That's not coming in our exam. Solution of linear differential equation of the type dy by dx plus py equals to q. That means dx by dy plus px is equal to q is not coming in your exam, right? With p and q are functions of x or constant. So this is only which is coming in your paper, and this is the thing which is coming in your paper, right? Now let's quickly understand few more things. Number one, what is implicit function? Now, what is implicit function? It is a function in which dependent variable has not been given clearly in terms of independent variable. Let's take an example. मान लीजिए x स्क्वायर माइनस 2xy प्लस वाई स्क्वायर इक्वल्स टू 0. तो यहाँ पर आपके लिए उसको जो फंक्शन है वो आपको क्लियरली स्पेसिफाई नहीं किया गया, और अगर आप इसका वेरिएबल सेपरेबल करने की कोशिश करेंगे इट्स गोइंग टू बी वेरी डिफिकल्ट फॉर यू, राइट? सेकंड, इम्प्लिसिट फंक्शन के बाद बात आती है एक्सप्लिसिट फंक्शन की. Now, what do you mean by explicit function? A function in which the dependent variable has been given clearly in terms of independent variable. For example, y equals to f of x. तो यहाँ पर आपका जो एग्जाम्पल है वो बेसिकली एफ एक्स वाई इक्वल्स टू 0 की फॉर्म हो गई. यहाँ पर y इक्वल्स टू f of x है. You can take one more example, y equals to e to the power x plus 1, or you can take one more example, y equals to ax square plus bx plus c, या फिर अगर y equals to sin inverse x plus 2, कुछ भी हो जहां पर आपको इंडिपेंडेंट वेरिएबल डिपेंडेंट वेरिएबल सेपरेटली नजर आ रहे हैं, दैट इज योर एक्सप्लिसिट फंक्शन. आई होप इट्स क्लियर. ठीक है, चलिए अब लेट्स स्टार्ट सॉल्विंग द क्वेश्चंस. Question number 1 which I am discussing is find the particular solution of the differential equation 1 plus e to the power 2x dy plus 1 plus y square e to the power x dx equals to 0, given that y equals to 1 when x is equal to 0. Now this question is from Cbse 2011-2019. How will you solve this question? First of all, What we'll have to do? Let's quickly repeat. This is your question. ठीक है, पहले हम जनरल सॉल्यूशन निकालेंगे. लेट्स अंडरस्टैंड व्हाट इज अ जनरल सॉल्यूशन एंड व्हाट इज अ पर्टिकुलर सॉल्यूशन. इस क्वेश्चन की हेल्प से आप बहुत आसानी से जनरल और पर्टिकुलर सॉल्यूशन का डिफरेंस समझ सकते हैं. जब हम इस क्वेश्चन को सॉल्व कर लेंगे और सॉल्व करने के बाद एक हमें आंसर मिलेगा विद आर्बिट्रेरी कांस्टेंट, तो वो हमारा जनरल सॉल्यूशन है. फिर आर्बिट्रेरी कांस्टेंट्स को एलिमिनेट करके जब हम एक पर्टिकुलर सॉल्यूशन निकालेंगे, मतलब एक पर्टिकुलर रिजल्ट निकालेंगे जहां पर हमने आर्बिट्रेरी कांस्टेंट की वैल्यू y इज इक्वल टू 1, x इज इक्वल टू 0 यूज करके निकाली होगी, वहां पर वो जो रिजल्ट आएगा दैट इज गोइंग टू बी आवर पर्टिकुलर सॉल्यूशन. सो लेट्स स्टार्ट सॉल्विंग द प्रॉब्लम. सबसे पहले लेट्स सेपरेट द वेरिएबल्स. The problem is can be written like this: 1 plus e to the power 2x dy equals to minus 1 plus y square e to the power x dx, which can further be written as dy by dx equals to minus 1 plus y square e to the power x upon 1 plus e to the power 2x. This can further be written as dy upon minus of 1 plus y square equals to e to the power x upon 1 plus e to the power 2x and dx, right? Further, this can also be written as minus of dy by 1 plus y square equals to e to the power x over 1 plus e to the power 2x dx. So as you can see, we have separated the variables. So it's very easy now. We can simply solve the question. We are using method of variable separable, integrating both sides, right? Now I think the problem has become very easy. I have solved many problems from integral, right? We have done many questions related to integrations from CBSE board previous year questions. So this is a very simple problem for you, I think. How will you solve it? Now, as you can see, your left hand side, you take minus sign common, you're getting dy over 1 plus y square equals to e to the power x over 1 plus e to the power x ka square integral dx, right? So your left side becomes minus of tan inverse y, which is equal to, how will you solve this right side? Right side may let us take e to the power x equals to t, which implies e to the power x dx becomes dt, right? So the numerator on the right side becomes your t dt upon 1 plus t square, right? So this will give you, what will it be? It will be tan inverse t plus c. So overall solution, what is it going to be? It will be minus of tan inverse y equals to tan inverse t plus c, which can further be written as minus of tan inverse y equals to tan inverse, आपने t की जगह वापस e to the power x put किया plus c, right? Now this is your general solution where you have an arbitrary constant. Now put x is equal to 0 and y is equal to 1 in the star equation. So what will you get? We get minus of tan inverse 1 is equal to tan inverse e to the power 0 plus c, which can further be written as you can see, tan inverse 1 is equal to pi by 4. How you get it? See, let आप लेके देखिए tan inverse 1 is equal to, आप थोड़ी देर के लिए u मान लीजिए, which can be written as 1 is equal to tangent u. So what is the value of tan u? कब tan u आपका 1 होगा? It's going to be tan pi by 4, right? And this is tan u. So value of your u is pi by 4. That means tan inverse 1 is going to be pi by 4. So I hope ये आपको समझ में आ गया होगा. tan inverse 1 जो है वो आपका u है और इस u की वैल्यू आपकी pi by 4 है. So minus pi by 4 is equal to tan inverse e to the power 0. So what is tan inverse e to the power 0? This is again tan inverse 1 plus c, which can also be written as pi by 4 plus c. So if you can see here, you will get c equals to minus of pi by 4, and this also goes to the other side. You will get minus of pi by 4, which will give you minus of 2 pi by 4, which can be written as minus of pi by 2. So the value of c is minus pi by 2. So here, this is your general solution. Now you're going to put value of c in your general solution. What will you get? Putting the value of c in star equation, we get, what will we get? We get minus of tan inverse y equals to tan inverse e to the power x minus pi by 2, which can further be written as pi by 2 equals to tan inverse e to the power x plus tan inverse y. So, hence, tan inverse e to the power x plus tan inverse y is equal to pi by 2 is the required equation. Now, as we all are aware that we are going to have 14 problems, out of which we may get a 3 marker or a 4 marker from this chapter, right? So now moving on to one more question. Let's shift to the next page. Another question which I'm discussing here is find, I hope everybody is clear what is the difference between a general solution and a particular solution. So now find the general solution of the following differential equation. Now this problem is from 2011 Cbse board. How will you solve the problem? We are provided with, oh, I've not mentioned the question. It's e to the power x 10 y dx plus 1 minus e to the power x sec square y dy equals to 0. So here it goes 10y. This is the given differential equation plus 1 minus e to the power x sec square y dy equals to 0. Let's quickly separate the variables. We'll get e to the power x 10y dx equals to minus of 1 minus e to the power x sec square y dy. Further, this will be converted to sec square y dy upon tangent y, which is equal to e to the power x upon e to the power x minus 1 dx. Integrating to both sides, what we'll get? Now, see, here let 10y equals to t, which implies sec square y dy becomes dt. Also, let e to the power x minus 1 is equal to u. So e to the power x dx becomes du. So we have this and this with us, right? We have all the values. So we are quickly putting in the values into the equation number 1. We get sec square y dy becomes dt. So we'll get dt upon t. So we have sec square y dy upon tan y, which is equal to e to the power x upon e to the power x minus 1 dx, which can further be written as dt upon t equals to du upon u, which can after solving become log of mod of t is equal to log of mod of u plus log of c. So what will you get here? log of t. T is equal to 10y. So log of 10y is equal to log of e to the power x minus 1 plus log of c. This can further be written as log of e to the power x minus 1 into c within the modulus. So therefore, what will you get? We get tan y is equal to e to the power x minus 1 c, right? And this is the required general solution. As we are not provided with any value of x or y, and they have already asked us for the general solution only, so we are not shifting further. We are not solving it more. Moving on to one more question. Now, the question we are discussing here is from Cbse 2016. The problem is solve x dy by dx plus y minus x plus xy cot x equals to 0. So how will you solve this problem? The given differential equation is x dy by dx plus y minus x plus xy cot x equals to 0. Divide whole equation with x. We get x over x dy by dx plus y over x minus x over x plus xy over x cot x equals to 0. As you can see, we'll get dy by dx plus y by x minus 1 plus y cot x equals to 0. Taking common, we have dy by dx plus 1 over x. Instead, you can write cot x plus 1 over x into y equals to 1. I'm writing it again because there is an overwriting. I request you not to overwrite while solving the problem, because I am working on the soft board. I'm doing it because I don't want to waste your time, but you are not supposed to overwrite. Otherwise, Cbse is going to cut your marks. I mean, they won't understand what you've written, so obviously your marks get cut. So dy by dx plus cot x plus 1 by x into y equals to 1. Now this is the problem. Now you compare the problem with comparing, give it equation number 1, comparing equation number 1 with dy by dx plus py equals to q. We get your p equals to cot x plus 1 upon x and q equals to 1, right? Now we know that now what we can do is, this is a linear differential, this is linear form, right? तो यहाँ पर हमें क्या करना है? यहाँ पर अब हमें इंटीग्रल epdx निकालना है, ठीक है? अब हमें ये चीज यहाँ पर फाइंड करनी है, इसे हम बोलते हैं इंटीग्रेटिंग फैक्टर. हमें इंटीग्रेटिंग फैक्टर निकालना है. तो चलिए क्विकली सॉल्व इट. e इंटीग्रल ऑफ cot x plus 1 over x dx, right? So whatever would it going to be? It's going to be e to the power log of mod of sin x plus log x, right? Within the mod. Why we get log of mod of sin x? I hope you all are clear with it. पर फिर भी चलिए आपके लिए समझा देते हैं छोटा सा. इंटीग्रल ऑफ cot x क्या होता है? क्या आप इसको cos x upon sin x लिख सकते हैं? Of course लिख सकते हैं. Let's use substitution method. Let sin x is equal to t. So cos x dx becomes dt. So therefore, integral of cos x dx upon sin x can also be written as integral of dt upon t, which is basically log of mod of t, which can be written as log of mod of what is t? Sin x, right? So यहाँ पे प्लस सी भी आता है अगर आप सिर्फ इसको इंटीग्रेट कर रहे हैं. So this that is why integral of pdx is giving you answer as e to the power log of mod of sin x plus log of x, right? So This can further be written as e to the power log of sin x into x in the mod, and which can further be written as your x sin x mod, that is x sin x. So your EP dx is equal to, which is your integrating factor, this is your x sin x. Right? Now x sin x is always positive. X sin x is always positive for any x. Right? Now, how will we solve it further? Now we have to solve the problem. Multiply both sides by integrating factor. What we'll get? We get x sin x dy by dx plus x sin x cot x plus 1 over x into y is equal to x sin x. ये बेसिकली हमने कहा किया, ये हमने हमारी मेन इक्वेशन में किया. We did this here. Okay, we multiply both sides with the integrating factor. Now we just have to solve the problem. We get x sin x dy by dx plus, here when you solve you will get x, यहाँ पर हो जाएगा when you solve, simplify करिए, you will get x cos x plus sin x into y equals to x sin x, which can further be written as derivative of y x sin x, which is equal to x sin x d y x sin x, which is equal to x sin x dx. Now integrating both sides, what we'll get after integration? We get y x sin x is equal to integral of x sin x plus c. Further, we have to solve the integral of x sin x, and we know how to do it. We have to use by parts, right? So let's quickly solve it by using by parts. Let your I is equal to integral of x sin x dx, which is equal to x into sin x. फर्स्ट फंक्शन आप आइलेट रूल यहाँ पर यूज कर रहे हैं, ठीक है? तो यहाँ पर आपका algebraic becomes your first function and sin x becomes your second function. So integral of sin x is minus of cos x minus integral x का डेरिवेटिव into minus cos x dx. This is by using by parts. Further, your I becomes minus x cos x plus integral of cos x is sin x. Okay. So putting the value of I in which equation? In your previous, यहाँ पर just a moment, यहाँ पर इसको हम इक्वेशन नंबर 2 दे देते हैं, यहाँ पे हमने पुट किया. So in equation number 2 we get y x sin x is equal to minus x cos x plus sin x. Constant हम एक ही बार लगाते हैं, यहाँ हमने लगा दिया, and then what we are getting, y x sin x is equal to sin x minus x cos x plus c. So therefore y equals to 1 over x minus cot x plus c over x sin x will be the required equation. I hope the problem is clear to everybody. I hope you are solving the problems, and watching the videos regularly. For more videos and related content, do watch my upcoming videos. Thank you and have a nice day.